Dear students, we're going to see something called as sequences and series today. Okay, so let's understand first of all what is a sequence and what is a series. So it says a sequence, an ordered list of numbers or a progression of numbers. Okay, so what is a sequence? Ordered list of numbers. Like, let me just give you an example. It can be something like this: 2, 5, 8, and so on, and 11, and so on. Okay, now it can be an arithmetic, geometric, or neither. Okay, a sequence can be either an arithmetic series progression or arithmetic sequence or a geometric, or it can be neither of them, and it can be finite or infinite. Okay, let's understand what is a series. Series is nothing but a value you get when you add up the terms of a sequence. So basically, when you add a sequence, which we are already seeing, when you add that, we get a series. So in other words, sum of the numbers in a sequence. Whenever we are expressing series, we use summation notation, that is sigma. Okay. Now let's learn certain basics. See, write the first 7 terms of an is equal to 4n plus 9. Okay. Now let me put n is equal to 1. If I put n is equal to 1 in this, see, this is my n. If I put n is equal to 1, what will happen? 4 into 1, that is 4 plus 9, and that will be 13. Okay, so that's my first term is 13. If I want to get a2, that means the second term. So 4 into 2, that is 8 plus 9, that will be 17. So my second term is 17. If I put n is equal to 3, so it is 4 3s are 12 plus 9, that is 21, and my a3 is 21. Same way, I'll get A4, A5, A6 as 25, 29, and 33 just by putting n is equal to 4, 5, and 6. Okay, let's move ahead. Okay, see, it says that find the 10th term of the sequence. What is the sequence? 2, 5, 8, and so on. So what is the concept? It says start by determining the pattern. Now, what is the pattern? If you look at these numbers very clearly, what is happening? When you add 3 to 2, we get 5. When you add again 3, we get 8. And that's how we'll get the terms next. So what is happening over here? Adding 3 to the previous number. This 3, whatever we are adding, is called as a common difference. So we continue the pattern to get the 10th term. So that's the reason it is 2, 5, 8. We go on adding 3. So it will be 11, 14, 17, 20, 23, 26, and so on. So the 10th term is 29. Okay. Let's go to the next slide. It says example. Okay. Determine a rule for the nth term of the sequence. See, there are these terms 1, 16, 81, and 256. This is the first term, second term, third term, and fourth term. It says when determining a rule for a sequence, you need to compare the term number to the actual term. Term numbers are 1, 2, 3, 4. If you look very clearly, what is happening? 1 raised to 4 is 1, 2 raised to 4 is 16, 3 raised to 4 is 81, and 256 4 raised to 4 is 256. So that is how we got the rule an as n raised to 4. Okay. Now, there are two types of sequences. One is called as infinite sequence and finite sequence. Infinite, very easy, a sequence that goes on forever. For example, 14, 28, 42, 56, 70, and so on. That's the reason, see, it goes on forever. That's the reason this is called as infinite sequence. Then finite, a sequence that has an end. For example, 1, 3, 9, 27, and 81. See, it ends over here. It has exactly 5 terms. Okay, so that's the reason this is called as an infinite sequence. I hope you have understood this. Thank you.